Our lesson today is going to be on scatter plots and lines of best fit. So first this says, real work data does not always fit into a nice straight line. Blank blank are often used to model this data so as to observe patterns and trends. And that is scatter plots. Not everything always comes out nice and neat. We might just have a bunch of random points that we're going to plot, and then we're going to figure out what kind of graph it is from that. So let's look at this first example. Using the data in the table, sketch the graph. A local football team has gained the following yardage in its first 7 games. So it shows us in game 1, they made 348 yards. In game 2, they gained 350 yards, etc. So we want to graph this information over on this grid and see what kind of scatter plot we end up with. Typically, the first column are your X's, your independent piece of information, but it doesn't have to be that. And the second piece of information are usually your Y's, your dependent piece of information, which means the yards they gain depend on the game they played. So the x-axis is this one. It's your horizontal axis. Your y-axis is this one. It's your vertical axis. So we're going to put game down here for the x-axis, and we're going to put yards over here for our y-axis. The y-axis is the dependent piece of information. The yards you gain depend on which game you played in. So let's look at our game information. We see the numbers 1, 2, 3, 4, 5, 6, 7. So I'm just going to figure out what kind of increments I want to go by, and 1 sound good. So I'm going to start this as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm going to look at the numbers for yards, and I'm going to put that along the y-axis. So I have to figure out what number I want to start with and what increment I want to go by. So if I went by increments of 10, there's no way I could get all the way up to 350. So what kind of increments might we go by? 50 sounds good. So let's make this 50, 100, 150, 200, 250, 300, 350, 400, and I'm going to go ahead and keep numbering up just a little bit more, even though I have got to my highest number in the list. And then this last one would be 500, which I don't really have room to write it because of my y, but that would be your 500. Okay, now I want to plot these points. So this is the x-coordinate, and this is the y-coordinate. X is what you do left and right. Y is what you do up and down. So I'm going to go right 1 and up 348. So right 1 and up 348. So I'm going to go just a little bit below the 350 and plot my point. Now I want to plot the point to 350. So 2 is your x-coordinate, 350 is your y, so you're going to go right 2 and up 350. Right 2 and up 350 and plot your point. And I'm going to keep doing that with all of my numbers. 300, I go right 3 and up 300. 295, I go right 4 and up 295. So I'm just going to go just a little bit below the 300 line again. 280, I'm going to go right 5 and up 280. So I'm going to go about halfway in between the 250 and 300. 250, right 6 and up 250. And 225, I'm going to go right 7 and up to 225, which would be halfway between 200 and 250. Okay. Does everyone have their points plotted? I hope so. If so, let's give you a smiley face. Down here it says to make predictions based on this data, a blank, 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 blank must be found. We need to figure out what's called a line of best fit. A line of best fit is a line that has about as many points above it as it does below it. So I'm going to look at these points that I plotted here, and I want to try to draw a line where I have about as many points above it as I do below it, and that's going to be called a line of best fit. It's a line that best accurately describes the information as well as it possibly can. So I'm going to try to figure out where I could draw a line where I have about as many points above it as I do below it. And I'm just going to go for it. Now everybody's line is going to be just a little bit different. So I'm just trying to draw a line where I have about as many points above it as I do below it. And this is called your line of best fit. Okay. Coming down to this bottom question, it says use the line of best fit to predict how many yards the football team will gain in game 9. So I want to figure out how many yards they're going to gain in game 9. So I am going to go to game 9 on the x-axis. I'm going to come up until I hit my line of best fit. Once I hit that line of best fit, I'm going to go over to the y-axis, and I'm going to see about how many yards that is that it looks like they gained. Anybody have an idea about what that would be? Maybe 145? So, this little symbol I'm about to write stands for approximately. It's two little squiggles. So I'm going to say approximately 145 yards. So what a line of best fit does is it allows you to make guesses on what's going to happen down the road. What could happen in game 10? You know, if I wanted to know how many yards it looks like they're going to score in game 10, you know, it looks just a little bit over 100. Now, of course, that doesn't mean that's what's going to happen. Maybe in game 10, they have a heck of a game and they gain 400 yards. So you never know. This is just an idea of what could possibly happen based on the trend that's going on. So that's called a line of best fit. All right, let's flip our paper over. So these are the three things that can happen whenever you draw a scatter plot. We can have this first picture, the second picture, or the third picture. This first picture, since it looks like the points are all going uphill from left to right, we call that positive correlation. As your x's get bigger, the farther right you go, your y's get bigger, the higher up you go. So as your x's increase, the y also increases. So as x increases, y increases, which means the farther right you go, the higher up you go. I also like to think of this sometimes as a more situation. For example, the more you work, the more money you make. I'm just going to write that example down. The more you work, the more money you make. That would be an example of positive correlation. More. The more you work, the more hours you work, the more money you make. Okay, this next picture. We see that the points look like they're having a trend of going downhill from left to right. So we call this negative correlation. As your x's increase, the farther right you go, your y's are decreasing, the lower down they're getting. So as x increases, your y decreases. And I like to call this a more less situation. For example, the more classes you take, the less free time you have. Let's write that example down. The more classes you take, the less free time you have. That's an example of negative correlation. The more classes you take, the less free time you have. And then this last one, the points are all over the place. It'd be really hard to figure out what line would have about as many points as it would below it. Would it be this one? Would it be this one? When they're all scattered all over the place, we call that no correlation. There's no relationship between x and y. So I'm just going to write no relationship between x and y. So when the points are scattered all over the place, there's no relationship between x and y. An example of this might be how many pets you have and how many books you read. There is no correlation between how many pets you own and how many books you read. So, example, how many pets and books you read. Those things have nothing to do with one another. Somebody might have 10 pets and never read a book. Someone else might have 10 pets and read 10 books a week. So no correlation there. Okay, let's look at this following example. It says the following scatter plot shows the cost of a phone call overseas in relation to the number of minutes per phone call. So it looks like the cost of calling depends on the number of minutes you talk. Remember, this is always the dependent information. So the cost it is to call depends on how many minutes you talk. So one says, what type of correlation exists? What do you guys think? That's right. That is positive correlation. If I were to try to draw a line of best fit, I would want about as many points above the line as I do below. So let's just try to do that now. Let's just try to draw a line where we have about as many points above the line as we do below. And like I said earlier, everybody's line is going to be slightly different, but the points definitely have an upward trend from left to right, which is why it's positive correlation. That is a more situation. Let me just write that down. More. Which means the more minutes you talk, the more it costs to call. All right, number 3 says use the line of best fit to predict the cost of a phone call lasting 60 minutes. So I want to know what the cost is if the phone call lasts 60 minutes. So where will I go to 60? Will I go to 60 on the y-axis or will I go to 60 on the x-axis? I'm going to go to 60 on the x-axis because that's in minutes. That's what I know. So I go to 60 on the x-axis because that's minutes, and I'm going to go up until I hit my line of best fit. Once I hit it, I move over, and I'm going to look to see where it hits on the y-axis. And I would say that that might be 19.20, something like that. So I'm going to say approximately $20. Now, depending on how your line of best fit looks, that will change exactly where you came over here. But hopefully everybody's somewhere in that $19, $20, $21 range maybe. Okay, number 4 says use the line of best fit to predict the number of minutes that a $12 phone call lasted. So I want to know how many minutes that a $12 phone call lasted. So I'm going to go to 12. Will I go to 12 on the y-axis or 12 on the x-axis? Well, this is how much I know, and it's in dollars, so I need to go to 12 on the y-axis. So I'm going to come over here to 12 on the y-axis. I'm going to move over until I hit my line of best fit, and I want to know how many minutes, so I drop down to see how many minutes. And it looks like somewhere between 30 and 40. I'm just going to say about 38 minutes. So, lines of best fit, they allow us to make predictions. Now that doesn't mean they're going to be accurate, but it allows us to make predictions the best we possibly can. So tomorrow we're going to try to fill out a summary, and we're going to try to come over here and try to ask some questions that maybe we can use to help us study from. That's it for tonight. Did you enjoy it? Smiley face!